click this green button, clone or download. And if you know how to use GitHub, you can use that. But for many of you, you just need a copy of the zip file. If I download this, I'm going to choose download. So once you download, on Windows, I know you can somehow read the zip file without even completely extract them. And so you need to completely extract them on the Windows. On Mac, apparently if I double click, then everything will be extracted. Then we are going to start from the first module. We're going to start using R with something called a simple r.rmd file. And then in my case, if I click it, it's going to be opened up by RStudio directly. If you don't see that sign, you should right click on that, then open it with RStudio. And if you just double click it directly, it may be opened up by R instead of RStudio. But you should open it with RStudio. And this is what you will see once you open up with RStudio. So what you are looking at is something called the R Markdown file. This is a Markdown file just to be used to run R code in RStudio. And the top part is just the header information, title, output. You can also add author, but we are going to skip it for now. That's minor part. And then those are the comment section. So anything between these three is single quote. That's something called a code block. That's something called code chunk or code blocks. So if you look on the right-hand side, top right-hand side of that block, there's a green arrow. I just hover my mouse on that green arrow. It actually says run current chunk. I click that, it does run it. So 2 plus 2 now it actually has the output at the bottom, say 4. So that's the run. That's some setting. This button is actually says run all chunk above. Well, if I click the bottom one, if I remove the result, I run the bottom one, say run all chunk above. It's going to run all previous chunk. It's useful when we are debugging the code. We made some change, and then need to rerun previous code only until the current line we are working on. That's a useful feature. So in a way, I'm using the R code just like a simple calculator. So if I want to say 2 plus 2, what do I want to add? And if you want to calculating the tip in a restaurant, let's say you just had the $46 bill, you want to get what? 15% tip, 18% tip, 0.08. And how much tip should we give? So that would be a 1.18, let's say. Yeah, 41.85, I guess. So that's the multiplication. And then we can also do, I guess, subtraction. 10 plus 7. What's that? The division? 27 divided by 3.0. Multiplication, addition, 1, 3. Okay. So yeah. So this is basically using R as a simple calculator. Minus backslash. That's the division. Star. The multiplication is a star sign. This pound sign actually means a title. That's just common. You don't have to use that, but we can do a simple calculation. What that does is actually can generate a report. If I say knit to HTML, you give me a report there, a simple calculation that become a title. And then every command and the result will be, all the results will be right after the every command. So that's a HTML report. I click this knit to HTML, yeah. But you may, once you do that, if this is the first time you are running it, you may have to install some package. So you probably need to wait a minute to do that. But it's actually a very useful feature for the reporting function, yeah, because it's here 10 minus 7 is 3, but on the actual code is actually at the bottom. They are not line by line. But once it's in a report, it's actually line by line. It's become more clear. And it's also good when, at least when I teach the student, the result and the code become more clear to explain. In my own work, I often use this also do something called, this is something called reproducible research. Because once I do this, I generate a report. I don't have to rerun many code. The code may take hours, even days to run, but the report can stay there. Okay, so I finished the code trunk, comment trunk, run selected line. Okay, then this part I have not tell you how to do that. So what if I just want to run one line in my code? And so I can do this. I can highlight one line, I highlight that. And then if you go to the very top, see run, I can click that run, see there's several options. Run selected lines, run current chunk, run next chunk. There's actually several of different, all chunk above, all chunk below, and restart run everything. And if I just say run current lines, there, it's actually just run pi to the second power. So it's a square, pi squared at 9.86. And the actual running result is a console. In my case, I have my console at the lower bottom, but you may or may not have that, depending on how you configure the window. So, and then on your right-hand side, you also see environment, history, or connections. Environment is the one you should pay attention to. Or in this case, I haven't cleared out the environment, so there are still something there. But if you just run it, it shouldn't have anything. In fact, if I can I click? No. I may have to remove everything. I forgot to clear the environment, so I'm going to clear my current environment. Okay, so you should have a clean environment to start with. So I forgot to clean my environment. So. We can also run selected trunk. Yeah. So I just I'm in the first trunk. If I run the second trunk, run the next trunk. There. That's the second trunk I'm running. So if I just using mouse to click that, that's the first trunk too. Yeah. So so we have a addition, division, multiplication. Oh, sorry, that's subtraction, addition, and then the power, keywords, pi. And then we can also have some other things like 2 to the third power, and log of pi, exponential function. EXP is, so this is the log and the EXP is actually using the default R function. So in this case, we have the smooth parenthesis with pi in the middle. The pi is a keyword, represent a number. So this is basically log is a function. I put the pi as the input parameter to that. If I don't use the pi, if I use the 10, I can use log 10. That should give me, let me do 100. That should give me 2. If I highlight that, that should, then I say run selected lines. At the bottom, it should give me 2. Yeah. So, and there's also shortcut. If you are really want to do things faster, you don't want to click. You see, on Mac is pound sign enter. On PC, I don't remember what's the shortcut. But if you hop on it, it's going to give you a what you are using to be. What's the what? Control enter. Okay. On PC is Control enter, and the Mac is that's the. I don't even know what's command. Yeah, that's symbol. Then enter. That's the. And if the exponential function of the 0 power to the 0 spot, that should give me a 1. If I run that, selecting line, it is a 1. In fact, I don't have to run this line by line. If I go to my HTML report, I can actually see, I should be able to see that. Yes, so exponential function to the 0th power, that is 1. So this is, the report is more clear than the actual code running. And then we can see the SQRT, that's the square root. It's also a default R function. So square root of 100, that's 10. Or then 100 to the 0.5 power, that's basically also square root. So that's also 10. It's just a way to, a different way to write the code. Okay, let me see. Okay, so I run, I covered all this part. Code trunk, comment trunk, selected lines, selected the trunk. Yes. Oh, no, that result is from actually this. Yeah, so it's not clear when you, because I only run the one line. But if I run square root of that, I didn't, and if I run that, its result is 10. The result will be line by line if you look at the HTML report. That this line by line, you only see that in the, if you knit, if I say knit to HTML, and then you will see that line by line.
No, to run HTML, why don't you just to install a bunch of other stuff? Follow packages, valid, digest, markdown, and so on.
Yes, if it's the first time you want to generate a report, it's going to ask you to install the necessary. Yeah. So, yes. Yeah.
So these actions show in the console as well?
You can also see the actual code is running at the console. Yeah. Yeah. So the console not necessarily at the bottom. You can, in fact, you can reconfigure the whole thing to anywhere you like. It's, but right now it's at the bottom left. So okay. I don't see red tag, so I'm going to moving forward. Okay, so right now, up until now, everything we do is a single number calculation, but R can do much more efficient than just single number. We can do something called arrays of vectors. So, and this is part. So, vectors or arrays. Basically, many number in a list. So one way to specify a list of number of the array is basically say 1 to 10. If I just type 1 to 10, if I type by the console 1 to 10, it is 1 to 10. If I say 5 to 15, it is 5 to 15. That's a list of numbers. But usually, so up until now, we didn't store everything in the memory. If you look at the right-hand side, the environment is still empty. There's nothing there. Because everything we type, even though it looks like we type into the computer, is actually the computer didn't memorize those things. If we want the computer to memorize something, we need to give it a name. So in this case, I type 1 to 10, the environment has nothing there. But if I say 1 to 10 with this arrow sign to X, and then it basically assigned to X. It doesn't have to be this arrow. It can be, say, X equal 1 to 10. This also works. But this left-hand side arrow, I guess, is more intuitive. Basically, either way, it works. So if I just run these two lines, and either one of them, if I run that, now if you look at the right-hand side, it actually says values. X is an integer, and is actually 1 to 10. There are 10 numbers there. This is kind of confusing. It's also the value of that 1 to 10 is also 1 to 10. Maybe I should change this. Okay, let me change that to 5 to 15 or 5 to 19 something. Okay, so and if I rerun this code, if I rerun that code, now it actually says now X is the integer vector 1 to 15, and it has a value with more than that. Okay, that's also not good. Change that to 5 to 9. Okay, now it's a 5 value 5, 6, 7, 8, 9. So that's the environment. And if I just run this whole chunk, there, it's going to just print out on the prompt. So this X is basically 5, 6, 7, 8, 9, but 1 to 15 is assigned to Z. So on the right-hand side,
Are semicolons necessary?
it is not required, but it's a good habit to put it there. Yeah. So you don't. So R is not a syntax stringent. If I don't put, it still runs. I forgot to mention. Yeah. So semicolon is a way to separate the lines, but you don't have to put that. If I do remove that, yeah. Actually, at the bottom, I didn't use it. So yeah. So the semicolon is not required, but is good habit. So it's a good style. So especially sometimes when you write a very long line and then you wrap it, then if you don't use semicolon, it becomes very confusing. So yeah. So in a way, sometimes it's a good habit to put it there. So. Okay, but apparently many of my code doesn't have semicolon. So, yeah. Okay, I'm going to quickly go over this and then move on to the actual case. So, and then the R function length of we can use length is a function of R, and we already use some of the function like square root, exponential, and log. And this is again a formal way to explain that R function. So smooth parenthesis is the R syntax to say is for the input parameter, and the X is the input value. So if for this line of code, X is assigned as 3 to 10, and the length of X. Okay, what do you think? Length of X will output. Some of you already say 8. Excellent. Yeah. So it is A. So, but if you don't want to run this, how do you find out what length can do? You can also look for the help. So if I say length, see at in this case, I pick the Windows say help. I put the length there. Yeah, it actually look for the length command. But in the code, you can also do this. You can also use something called question mark or help length, and that also give you the. If I type help length, it's actually give the same thing. So it also leads to the same help page. So looking for help basically just can use a question mark or help. That's the, or you can just type it directly in a window in the GUI interface. So. And then one of the reasons why it's so popular is really data visualization. It's a very quick way to visualize data. So if we have two variables, x and y, we want to see do a scatter plot. I'm going to make sure x has something. X is a 3 to 10. And then y is the x plus 4, I guess. Yeah. Before I do that, and there's also a make sure we need to go over that. This equal sign programming means. So for people who are new to coding, this equal sign in computer science is not the same as in math or other discipline. If we say x equals 3 to 10, and then we say x equal to x plus 1, it seems to be just making no sense in math. But in computer science, the equal sign really means assignment. Left-hand side move to the, sorry, right-hand side move to the left-hand side. So basically, the x plus 1 is right-hand side. Basically, what I'm saying is x is 3 from 3 to 10, but then every element increment by 1. But then I assign the entire thing back into x again. Basically, what I'm saying that everything in x increment by 1. I can do other things. If I say x multiplication by 2, every element in x is double. So that sign is really means assignment, not the equal or equivalent in the math context. So. Okay. And then we can do a simple plot. So if I run x there, and then a simple plot there. So y is just x plus 4, and then we do a simple plot x over y. Oh, I actually did it twice. If I just plot, run selected a line, yes. This is y over x, y tilde x. And if I switch it x tilde y, and it just reverse the vertical and horizontal one. So this is x over y. So I can also add a title. I can say the title is something called in the main in the parameter. This is x over y over x, and the bottom one is the x over y. And once we add the label, the plot become more clear. There. So the first one, can adjust the window. Okay. The first one is y over x. The second one is x over y. So that's a simple plot. We can also do a plot with different symbols. This is part of the coding. So the symbol is represented by something called PCH, but I never remember them. So every time I want to use them, I just run everything and see which symbol I want to use. So there. So x is from 1 to 25, and then I just plot every symbol from 1 to 25. And usually that probably is 19. That's the symbol I often use. PCH equal 19 is this solid big circle. That's all you can pick. The triangle, that probably is 17, 15, 16, 17. Oh, those symbols are represented by the numbers. So if I say PCH equal 19, everything will be the black circle, black solid circle. I changed that into X. The symbol, the from 1 to 25. If I say 1 to 25, yeah. Yes. Basically, the X is 1 to 25. I plot every possible symbol from 1 to 25, and then I pick which one I want to use. So that's the. Honestly, I don't know what PCH stands for. I only know. Yeah, it's just the symbol. Point character something. Yeah. Okay. Some people actually know what it stands for. Yeah. I'm not sure. We can try. I can say 30 or 50. See whether it give me a bug or not. No, it still probably goes to 255. I bet. If I go to a 256. No, then it gave me an error. So yeah, I probably shouldn't do it. 127 probably still works. So. Yeah, 127 still works. Goes more than that, it gave me an error. So. In fact, the plotting function is probably one of the most complicated functions in our many package customized plot and rewrite it. So very often, at least in my own work, I spend probably 20 in a project. Sometimes I spend at least 50% of my time just study the plot, how to generate a publishable figure. That's there are many ways to generate a plot, and right now we are just using the base package plot. But there are many other plotting functions, including ggplot. Actually, I'm not even covering them in this bootcamp. I only cover with the very basic things. So, but if you Google online, there's many. DataCamp is a good resource to do that too. So, but even for the simple plot, if I say plot x where y main, if I put some other parameter like type, it also can give a fairly sophisticated plot. So there. Oh, I typed it wrong. So this is type B. This is type B, but how do I know type B do this? Basically, I try different, read the manual and try different versions. If I just run, I should just click, say, run that line, but I click the wrong button. Run selected line. Yes. Line by line to line plot. I'm not sure why that goes around. Probably the X and Y are reassigned. So. Okay, so now I need to go over you some very basic syntax of R. In R, what if I want to define a customized, a specified value? And you can use something called C and then with parentheses. This is something just to specify an array. So in this case, I say x equal 0.1, 0.3, 1, 3, 5, 10, 0, 0, 1, 0.913. That's basically what the x. If I highlight that line and then I say select, and then you look at on the right-hand side, there, that's the value of x now. That's the value. I specify that value. But what's the element from the 4th to the 6th? I can highlight that line and then run it. There. So if I can. So, and this is the part, R is just opposite to MATLAB if you use MATLAB. So MATLAB, they switch the square bracket and smooth the parentheses. And R just use the opposite way. So yeah, sometimes using both MATLAB and R can be confusing. Even nowadays, I still confuse myself. Yeah. But once I type it, it gives me an error and then change it again. So yeah. And so the second will be the second value. Well, if I count 1, 2, 3, 4. So R, the first element is 1, not 0. And for those in computer science, you just need to remember this. Python, the first one is 0. Or Java or C or anything else. Yes. Yes. Yeah. Indexing. That's indexing. Yeah. In fact, I'm indexing number 2. Number 2 is 1, 2. That number 2 shall give me 0.3. So if I highlight that line, select 0.3. So that's 0.3. I can also index in multiple positions, right? So yes.
Why doesn't change X in the environment?
Oh, the X and Y, I never assign them. I just indexing what's in X and Y. So those are only when I assign them, it will change. I just type X, I never assign, I never change them. I just.
So if you put X equal to square parentheses 2, it will change.
Yes, I believe so. In fact, we can try that. If I say X equal X plus 2, then everything will just become one value. So indeed. So yeah, but that would be yeah, that's not what I intended to. Yes.
So what is the difference for array being a number array versus an integer? Like Y and Z, that's the difference.
Oh yes. So Y is a number because those are floating point. You have decimal, but the Z is just integer.
Would that change anything if you're running?
In most cases, it doesn't change anything. Yeah. Only when you really do some type sensitive coding, then it will change something. For now, for most data analysis, it shouldn't matter. That's by default. If I say X equals say 3, if I say C 1, 3, 5, 7, that should give me an integer. If I run that line, now oops, that's still a number. Okay, I'm surprised. Okay, yes.
Clarification.
Mhm.
So when you say indexing, what is indexing?
Found out the position, found out the say i's position in an array, I guess. Yeah, indexing with I. If I want to say, an array. That basically is i's position. And in R, this start with 1, not 0. I'm actually a bit surprised when I say 1, 3, 5, 7, it still give me a number. But if I change that to W with that, that's still a number. Okay. Yeah. Okay. Well, but yeah.
I think
question is the difference.
Yes. Actually, didn't know that. So every time I have been using R for actually more than 20 years now since graduate school. So, but still, there's many new things. In fact, probably every day there are new things in R I don't know about. So, yeah. Okay, so those are indexing. So this is actually customized indexing. If I want to index in 152, do I actually have 152? Actually, I don't. I need to reassign my X back. So because I just deleted with the indexing. So this is, I guess, this is part of when you do interactive coding. Sometimes the result already changed, you don't remember, and then you want to make sure you rerun all the code and just to keep your sanity, I guess. Yeah. So I'm going to rerun everything. This code. Oops. Oh, I need to comment out this plot line because the X and Y are also not there anymore. So okay. Okay, so if I run that, and then if I do the indexing X, so the first one is 0.5. The fifth one is 5. Is that correct? 1, 2, 3, 4, 5. That's correct. Second one is 0.3. So I'm indexing the first, fifth, and second. I can also indexing. I vaguely remember we can indexing this, but I'm not sure. Indexing -1. No, that's not doing what I want. It just remove the last one. Sorry, it actually removed the last one without indexing. Okay, and again, just simple plotting. And you can also change colors. In this case, if I say color red, green, blue, and gold, and then I do the plotting. Yeah, that's just red, green, blue, and gold. That actually is the four school. Oh wait, except this green. Yeah, if there's light blue, maybe that's. I'm not sure whether there's a light blue. Let me try that. Oh, there's a light blue. Okay, good. So, yeah, so that would be Tuskegee, Spelman, West Virginia, and UTC. So, yeah. Okay, so all right. I guess let's. Yes.
Just have a quick question.
Mhm.
I'm a SAS user, so semicolons are very important.
Mhm.
You use them some ends of your line and
Yeah.
others.
Yeah. I'm not very strict person to follow the syntax. The R is not a strictly enforcing that semicolon, but it's good habit to put it there. This is right now. It's we are writing very short lines. It doesn't matter. If I often write very long lines and then erect back. If I don't use semicolon, then I basically confusing myself. So it's good habit to put it there. But it's just so easy to forget to put it. So, yeah. Okay. That's the simple R part.